Good morning students. Today let us discuss the unit 2. In the last class I already given the introduction about the unit 2, that is knowledge representation and reasoning. And we discussed what is knowledge based agent and what are the techniques and approaches for knowledge based agent. Today let us discuss the first technique in this knowledge based agent, that is propositional logic. So in this session I am going to discuss about the propositional logic and the predicate logic, which is one of the technique how we are going to represent knowledge to the knowledge based agent. Propositional logic. So what do you mean by this propositional logic? Propositional logic is nothing but a declarative statement which is having one of the two values, that is either true or false. We can also call this propositional logic as Boolean logic. Even this Boolean logic also we are going to have only two values, that is 0 and 1. So and in this propositional logic we have two types of propositions, that is the statements. Those are called as the atomic propositions and compound propositions. And there are some rules to follow how a propositional logic is to be implemented. That is, it should be compulsory represented by variables like either A, B, C or P, Q, R. Okay. And there are two important concepts in this propositional logic. One is tautology and contradiction. But before going to this tautology and contradiction, first we need to know what is this atomic proposition and what is this compound proposition. Suppose there is a statement, it is raining. We can say that this is atomic proposition. Why? Because we have only one statement. Suppose the same statement, one more, it is raining and street is wet. Then we can say that this is a compound proposition. Compound propositions are formed by combining two atomic propositions. That is, this is one atomic proposition and this is other atomic proposition, and these can be connected by using one of the connective. Like this, we have 5 number of connectives in propositional logic. Those connectives generally we call it as the logical connectives. Those connectives are and, are, not, conditional and biconditional statements. Each of this let us represent with the help of a truth table. So let us take that I already told you each variable can be represented either by A, B, C or P, Q, R, whatever it may be, but it should be represented in capital letters. So we know that we have 4 truth values, that is true true, true false, false true, false false. And we have and can be represented by P and Q, R can be represented by P or Q, not can be represented by either negation P or negation Q. Then the next one is the conditional statement, that can be represented as P conditional Q. And then biconditional, it is represented as P biconditional Q. So coming to the AND logical connective, when both inputs are true, then only it will be true. In remaining all cases, it is false. Then coming to the OR logical connective, either of the any one input is true, then the output will be true. That is true, true, true. As both inputs are false, then only it will be false. Then coming to the negation P or negation Q, when we see this negation P, whenever there is a true, negation P indicates that it is a false. Whenever there is a false, negation P indicates that it is a true. In this way we are going to represent negation P or negation Q. Then the next one is P conditional Q. Here P conditional Q, whenever P is true and Q is false, then only it will be false. Remaining all conditions, it is true. When P is true and Q is false, then only it will be false. In remaining all conditions, it is true. That is what the conditional statements. And coming to the P biconditional Q statements, when both inputs are same, that is either true or false, and that cases only it will be true. Remaining all cases, it is false. When both inputs are true, that is when both inputs are same, then only it will be true. Otherwise those two are remaining cases, it is false. So this is the logical connectives. With the help of these logical connectives, we are going to form the compound propositions. Okay, so it is raining and street is wet. So let us say P equal to it is raining. Let us represent this statement with a variable P. Street is wet. Next one is street is wet. that is represented by another variable Q. So it is raining and street is wet, that is P, and is nothing but represented by a symbol called as this one. So P and Q. So this particular atomic propositions can be represented in this way. Suppose conditional and biconditional. Suppose if Raju studies well, then he will pass the exam. This is a one statement and asking you to convert it into symbolic form. If Raju studies well, then he will pass the exam. So let us represent P. Raju studies well, okay, and let Q will be Raju will pass the exam. Okay, this such type of statements. If then, in a particular statement, if you find if then it is represented by conditional. That is, so P conditional Q. That is, P represents that if Raju studies well, then Raju will pass the exam. So that is what the conditional statement. Then coming to the biconditional, it is nothing but one more name is if and only if. That is, Raju will pass the exam if and only if he studies well. Such statements can be represented with the help of P biconditional, that is P conditional Q. So this, if the same thing is represented in this way, we can rewrite the statement as Raju will pass the exam if and only if he studies well. So in this way, these logical connectives are represented in propositional logic.